Okay, so this one is an incompletely specified state table. So we have basically some don't cares. So I've got some things in here that are they're just lines. So they're don't care. So they can be anything. And the way to go about it, if you wanted to really make sure you had the minimum state table, you would try all the different possibilities. But you don't have to do that. You can just assume something, you can make your best guess as to what's going to make it minimum and use that. So what we'll do first, well, the first partition is always going to be putting them all together. And you can call this P1 or P0. I think I've seen them do it both ways. And our second partition is going to be to break them up just based on the outputs. And so if we look at our outputs, so far we have a 1, 0, a 0, 1, a 1, 1, and a 0, 1. And so we have 1, 0, 0, 1, 1, 1. So the only thing we don't want to do is we don't want to add a 0, 0. So there'd be no point in making an additional state. And so we can just make these be the same as some other state, and you can just choose what you want. Let's make them both zeros. And that means what you get may be different from what someone else gets. So now I'll divide these up based on their output. So everything that has 1, 0 will go together. So 1, 0 is A and E. And then everything that's 0, 1, that would be B, and C, and F. And then 1, 1 looks like it's D. Did I get everything? A, B, C, D, E, F. Yep. Okay, now I'll check my 0 successors. So I'll look at A and E. A goes to C, and E goes to A. So they have different 0 successors, so they have to be split up. And then B goes to F. C, let's come back to C. F goes to B. So in order to keep these together, because that would be your goal, to have as few states as possible, we'll let C go to B. So now that keeps them all in the same group. D's already by itself, so we don't need to check it. Now we'll do the 1 successors. A and E are already by themselves. So now let's check B. B goes to D. C goes to E. So they have to be split up. So I have B in one group and C in another group. And F goes to D, which is the same place B went to, so we can keep those together. So now we can see that we didn't do a whole lot here. The only two that we've managed to keep together are B and F, and now I'll just double check and make sure that they are going to the same place. So when W equals 0, B goes to F, and when W equals 0, F goes to B, so that's fine. When W equals 1, F goes to D, and B also goes to D, so they're fine. Okay, so this one, the only two we combined were B and F, and so if I do my state table here, I would have A, B, C, D, E, and F. What do I do not need F. And then A goes to C and A and 1 and 0. B goes to B, D, 0, 1. C goes to B, E, 0, 1. Actually, for C, I'll put in B. D is A, E, 1, 1, and E is A. And did I ever say where this one went to? I didn't. I can just say A and 1, 0. Okay, so that did not really give us a very good minimization. It's not wrong, but it's not very good. And so maybe we might get something better if we made a different assumption at the beginning. So let's try that and see what happens. Okay, so let's try this now with making them, let's see, let's try making them both 1s. And then our second partition would have, let's see, our 1, 0 outputs is just A. Our 0, 1 output is B and F. And our 1, 1 outputs are C, D, and E. And now let's check our 0 successors. So A's fine. B goes to F, F goes to B, so they're going to stay in the same group. C, we don't know yet. D goes to A. E also goes to A, so let's let C go to A. So then they'll stay together. Now we'll check our 1 successors. B goes to D, and F also goes to D, so they'll stay together. C goes to E, D goes to E, and E we don't know, but how about we say E goes to E as well? And then those will stay together. Now we didn't make any change since we found the 0 successors, and so we know it's going to be good. I don't have to go back and check it. I already know they have the correct 0 successors. So this time my table will look like this. And I will choose my representatives to be A, B, and C. And so B, when W is 0, B goes to F, F is state B, same as B, and W equals 1, B goes to D, that's the group that has C in it. C is A, and E is group C. And output for B is 0, 1, and for C is 1, 1. So this one is a little better than the first one. And you don't really know that until you try it. And it's just, I don't think you'll be required to necessarily find the best one, because if you wanted to absolutely make sure you found the best one, you would have to try, for these outputs, you'd have to try the combination 0, 0, which we did, 1, 1, which we did. You could also try the combination of 0, 1, and you could try the combination of 1, 0. So since there are 2 that are incompletely specified, that gives you 4 different possibilities, not even accounting for the fact that you have different possibilities over for the next state as well. you clearly want to choose the next state to be the one that gives you the best outcome if you can see what that's going to be. But that's how you would do that. Let's see. Any questions on that? Okay, would y'all like to try one on your own? Or do you think you understand?
You good?
I heard one person say good. Nobody has said anything else. Let's see.
I think I'm good.
I think you're good? Okay. So, any questions on anything